Hello friends, hearty welcome to you. Let's continue with examples on increasing and decreasing functions. So we have couple of examples to solve. Let's try to solve them together. The first one we have, so for all these examples 1, 2, 3, 4, we have to find out the interval on which the function is increasing or decreasing. So let's do the first one. We know f of x is equal to, since you are aware of this, we'll do this pretty fast. 2x cube plus 9x square plus 12x plus 20. So f dash x is equal to derivative of this, that is 6x square plus 18x plus 12. And we know that we have to first equate the we have to find out the point where the derivative is 0 so that we can divide that into intervals. So I'll say f dash x equal to 0 gives me 6 into x square plus 3x plus 2 is equal to 0. That gives me 6 into x plus 1 into x plus 2 is equal to 0. That means x equal to minus 1 or x equal to minus 2 are the points at which the slope is 0. So let's draw the number line. We have minus infinity, we have infinity, then minus 1 and minus 2. So I'll put down minus 2, minus 1 here. So this is what we'll have. Okay. Now what is our f dash x? F dash x is 6 into x plus 1 into x plus 2. We will take this part. 6 into x plus 1 into x plus 2. Now we will choose some random values between in the interval. Let us choose minus 3 here, and let us choose, let us say minus 1.5 here, some value. Here I'll choose 0. So we'll see by putting those values how the slope is. At minus 3 it will be f dash of minus 3, that's equal to 6 into minus 3 plus 1 into minus 3 plus 2, that's equal to 6 into minus 2 into minus 1, which is positive. So in the interval minus infinity to minus 2, the function is increasing. Now let's go to minus 2 to minus 1. For that we will check f dash of minus 1.5, that's equal to 6 into 1 minus 1.5, that is minus 0.5, into 2 minus 1.5, that is 0.5, and I see that is negative. So between minus 2 to minus 1, the function is decreasing. Now let's look for minus 1 to, after that we have minus 1 to infinity. We'll check for 0 here. If I put 0 here, 0 plus 1 is 1, 0 plus 2 is 2. So I have again positive. So you can see that the function is decreasing. The function is decreasing in the interval minus 2 to minus 1. So I can say the function is decreasing in the interval minus 2 to minus 1, and the function is increasing in the intervals minus infinity to minus 2 and also minus 1 to infinity. So that's about the first problem. So it's a simple, we have to find out the derivative, then equate it to 0, find out those points, then put it on the number line. Then we have to take some sample values for each interval, try to find out the slope, how it is. Based on that, if the slope is positive, it's increasing in that interval. If slope is negative, it's decreasing in that interval. So let's do one more problem. Second one, we have f of x is equal to 2x cube minus 15x square plus 36x plus 1. F dash x is derivative of that. 2x cube, x cube is 3x square, 2 into 3x square, 6x square, x square derivative is 2x, 15 into 2x is 30x plus 36, which I can write it as 6 into x square minus 5x plus 6, which is nothing but equal to 6 into x minus 2 into x minus 3. So now I have to equate the derivative to 0 to find out the points where the slope is 0. So I say f dash x equal to 0 gives me 6 into x minus 2 into x minus 3 equal to 0, or x equal to 2, or x equal to 3, the points where the slope is 0. Now we can go to the number line. We will have minus infinity, infinity, we have 2, we have 3, so divided into 3 intervals. Now minus infinity to 2, 2 to 3, 3 to infinity. First we'll check a value here. I'll take 0 here. 0 is my value here. Here I'll check 2.5. Here I'll check for 4. If I take 0, 0 minus 2 is minus 2, minus 2 into minus 3 is 6, 6 into 6 is 36. So the function is increasing because the value is positive. How we got it? We checked for f dash 0 equal to 6 into minus 2 into minus 3, which is equal to 36. That's positive. Now then we will go to 2 and 2, between 2 and 3. So I'll check for f dash of 2.5. That's equal to 6 into 0.5 into minus 0.5, which is negative. So I will say the function is decreasing between 2 and 3. Now let's take another value, let us say 4. We know this is increasing, but we just want to make a point here. If I do f dash of 4, that's equal to 6 into 4 minus 2 into 4 minus 3, that's equal to 6 into 2 into 1, which is equal to 12, that is positive again. So we know that the function is decreasing between 2 and 3 and increasing at the remaining intervals. So we can write it as function f of x is increasing in the interval minus infinity to 2 and 3 comma infinity, and decreasing in the interval 2 to 3. So let's do one more problem. We have f of x equal to sin x minus cos x. We are interested in 0 to 2 pi. So we'll find out what is f dash x. F dash x is sin x derivative is cos x, and cos x derivative is minus sin x. Minus of minus will become plus. So f dash x is cos x plus sin x. Now we have to equate f dash x equal to 0 to find out the points where the slope is 0. So cos x plus sin x is equal to 0, or cos x equal to minus sin x, or I have tan x equal to minus 1. And where the tan x is minus 1, it is tan x is minus 1 whenever it is x is 3 pi by 4 comma 7 pi by 4. These are the two places where the tan of the angle is equal to minus 1. You have tan pi by 4, which is positive because first quadrant. 3 pi by 4 is negative. 7 pi, next 5 pi by 4, that is positive because tan is positive in third quadrant. We have all silver teacups. So tan is positive in first and third. So second and fourth, where you have it negative. So now what we know that it has to be divided into minus infinity. Then you will have 3 pi by 4, then you will have 7 pi by 4, and we will have infinity. Oops, it's not infinity actually. We are interested in 0 comma 2 pi. We are interested in only 0 comma 2 pi. So I'll put it down. We'll say 0 comma 2 pi. This is 0 and this is 2 pi. Now let's take some sample values here. Between 0 to 3 pi by 4, I can take pi by 2. Okay, fine. 3 pi by 4 to 7 pi by 4, I will take pi. We will see this one also. Okay, right. We'll take some value here. Let us say 7 pi by 4 is 315 degrees. I will take something like 350 or 320 or let us say 330. I can take 330 degrees. I don't know what it is in pi. 330 into pi by 180, 33 pi by 18, something like that. We'll just leave it in degrees for now. If I take pi by 2, what is cos pi by 2? Let us do that here. F dash of pi by 2 equal to cos pi by 2 plus sin pi by 2. You know cos 90 is 0 and sin 90 is 1. So the function is positive between 0 and 3 pi by 4. Now let's go to the next one. We'll go for f dash of pi, that's equal to cos pi plus sin pi. You know sin pi is 0 and cos pi is minus 1. That means the function is negative or decreasing in between 3 pi by 4 and 7 pi by 4. Obviously it should be increasing in the next one, but we will check it. We took 330 degrees, so I will say f dash of 330 degrees. I won't convert that into this, so I will say cos of 330 plus sin of 330, that is nothing but cos 30 plus sin 30, because sin of theta is sin of 2 pi minus theta. Similarly cos of theta is cos of 2 pi minus theta. You have both positive values adding up to another positive value. So the function whatever we have is increasing in the interval 0 to 3 pi by 4 and 7 pi by 4 to 2 pi, and the function is decreasing in the interval 3 pi by 4 comma 7 pi by 4. So that's how we can find out the intervals in which the function is increasing or decreasing. We'll have one more problem. We'll try to finish that one too. We have f of x equal to log of 1 plus x minus x by 1 plus x. So we have to find out f dash x. Logarithm of 1 plus x, derivative of that is 1 by 1 plus x, minus, you have u by v formula here. So u by v formula derivative, u by v derivative is equal to v into u dash minus u into v dash by v square. So we'll have 1 plus x whole square, and we'll have 1 plus x into derivative of x, that is 1, minus x into derivative of 1 plus x, that is equal to 1. So if I simplify this, I will have 1 by 1 plus x minus 1 plus x minus x, that's nothing but 1 by 1 plus x whole square. We can simplify this. It will be 1 by 1 plus x into 1 minus 1 by 1 plus x, that's equal to 1 plus x minus 1, x plus 1 minus 1 is x, so it will become x by 1 plus x whole square. So this is our f dash x. So now we want to find out the intervals on which the function is increasing or decreasing. So we will have minus infinity to infinity, and x equal to 0, f dash x is 0 will give me, f dash x is 0 will give me x equal to 0. So we'll have 0 there. We will have 0, and we'll check for values between 0 and infinity. Suppose I take a positive value, then you know 1 divided by, you know that square of any value is always positive, because even it's negative also, negative into negative will become positive. So between 0 to infinity it is positive, and if you look at the slope when you have negative values, when you look at the negative values, you will see that when I take, suppose I take minus 2, it will become minus 2 divided by 1 minus 2 whole square, that is nothing but negative. Now only the thing we have to remember here when we define the function, that x not equal to 1, something like that we should say. Otherwise we should exclude that particular minus 1 in this one. X not equal to minus 1, because when x becomes minus 1, then we will have this particular value will be not defined. Okay, we'll just leave that, that's fine. This is what is we have given. So we know that the function is increasing between 0 to infinity, and the function is decreasing between minus infinity to 0. So I can say decreasing minus infinity to 0 and increasing 0 to infinity. We'll solve a couple of more problems. So f of x is x cube minus 6x square plus 12x minus 18. The first step we have to do is find out its derivative, that is 3x square minus 12x plus 12. So which is nothing but 3 into x square minus 4x plus 4, or can I write it as 3 into x minus 2 whole square. F dash x is 3 into x minus 2 whole square. So at x equal to 2, the slope is becoming 0. So we'll put it down. Minus infinity, we have infinity and we have 2. Okay, so we have to check for values here. So I'll check for 0 here and I'll check for 4 here. First we will do f dash of 0, that's equal to 3 into 0 minus 2 whole square, that's equal to 3 into 4, that's equal to 12, which is positive. Similarly, f dash of 4 is equal to 3 into 4 minus 2 whole square, that's equal to 3 into 4, again that's equal to 12. It's positive. So actually without doing any calculation, you can immediately tell that whenever you are squaring a number, it's always positive. Because even it's a negative number, when you square it, minus into minus will become positive. So the function is increasing between minus 2 to 2, minus infinity to 2 and 2 to infinity, or can I say the function is increasing throughout R. The function is increasing for any value on the number line, we have the function increasing. So that's some examples related to increasing and decreasing functions. We will move to next topic, that is errors and approximations, in the next session, where we will look into how to find out the square root or cube root approximately. So that is about increasing and decreasing functions, the summary of which is to find out whether a function is increasing or decreasing in a particular interval, we have to find out the derivative, because if you look at the curve, the slope tells you whether the function is increasing or decreasing. If the slope is positive, then the function is increasing. Slope is negative, the function is decreasing. But the slope is nothing but equal to derivative for us. We know that dy by dx is equal to tan theta, that's also is equal to slope. So we will find out the derivative, equate it to 0, find out those points where the derivative is 0, then based on that divide the number line into those intervals and check, taking some sample values from the intervals, we'll find it out whether the function is increasing or decreasing at a particular interval. So thanks for your time and support. Bye for now.